Good morning, class. Today, we're going to talk about the sun and its core.
So does anybody know anything about the sun and its core?
Yes. The sun provides light and heat for the earth.
Good job, Jenny. So to get the class started, we are going to first watch this video of the core of the sun. And this video will just kind of get you guys thinking about the processes.
So in this video, you're going to learn about nuclear fusion and what it does to heat the sun that provides heat for the earth. While we're watching this video, we're also going to have the closed caption up so you can visually see what's happening, but you can also read along too.
So let's get the video started.
Unknown on Earth that was powering the sun. In the 1920s, scientists found the answer to the puzzle in a process that would later be harnessed to fuel the hydrogen bomb, nuclear fusion. Fusion occurs when atoms are smashed together at a high rate of speed and literally fused. To get this to happen, conditions have to be just right.
For any interaction to happen, these two protons each has a positive electric charge, and so they would repel each other. So you've got to get them close enough together. And to do that, it's got to be hot, which means particles move very fast, and dense enough that they hit each other and they can get close enough together that they actually fuse.
The core of the sun is the perfect cauldron for nuclear fusion. It's the hottest place in the solar system at a sweltering 27 million degrees Fahrenheit, and it's also incredibly dense.
It's so dense, it's 10 times the density of lead. And you would think at that density it should be a solid, but it's not because it's so hot that it remains a plasma.
If you heat a gas to high enough temperatures, electrons fall off of the atoms and they float around in the soup. And so it has behavior that's different from what a gas would do. And so we have a different word for it, call it plasma.
To truly understand what goes on in the core of the sun, you have to find some way to imagine the almost unimaginable.
In addition to studying the sun, I also play pool. And the sun is a place where there are billions of particles colliding and interacting with each other. And it's really not unlike a cosmic pool table on an unimaginable scale. It doesn't matter how hard you hit a ball. You would never hit it hard enough to actually fuse that ball together with another ball. But there's so much pressure and such high density at the core of the sun that the two objects impacting each other will actually fuse.
In the sun, these objects are hydrogen atoms, flung together by immense pressure to form helium atoms. In this fusion process, the resulting atom is slightly less massive than the ones that created it. The missing mass is given off as energy. Each second inside the sun, 600 million tons of hydrogen are fused into 595 million tons of helium. That 5 million tons of mass lost in the process is converted into energy equal to 1 billion 1 megaton hydrogen bombs. That's every second.
When you look out into the cosmos, the process that gives you the highest return of energy for free is what goes on in the centers of stars like the sun.
So we now know that the sun is powered by nuclear fusion. It's the only fuel that we know that can sustain the burning in the sun long enough to sustain life on Earth. Billions of years.
So now that we have watched the video, got some of our background knowledge on the sun, brought to the forefront of our brain, we're going to talk about another question. We're going to discuss how big is the sun compared to the earth. So you can use different analogies you might have heard, but what we're going to do is we're going to break off into 3 groups. I'll just count you off and we'll discuss this question. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Ones are going to be up front, 2s are going to be in the back middle, and 3s are going to be over in this corner. We'll give you about 5-ish minutes to discuss this, and then we're going to come back.
We look like a marble next to a bowling ball. I think we look like a speck of dust, guys. I mean, look how small we are compared to that giant mass.
So after we give them the 3 minutes to have the small group discussion, we would bring them back together as a class. And once we're here as a class, we would discuss what they talked about in their small groups, but we would also discuss how the sun is a star and how nuclear fusion plays a part in how luminous a star is. And the brighter, the more luminous the star is, that means the more nuclear fusion that is happening.
We're going to get started with our popcorn experiment, and during this experiment you guys are going to be observing, taking notes, and trying to make connections on how what is happening with the popcorn is actually related to nuclear fusion. And then this experiment will it'll set the ground for what nuclear fusion actually is.
So in nuclear fusion, what you are really going to experience with this popcorn is how the popcorn, which would be considered the atoms, are popping all around, moving at fast pace to create something bigger, that luminous sight that we see. And you'll also see how photons play into this and how atoms move different directions to create something. So let's make some popcorn, guys.
All right, so if you guys want to head over to our stations, you're going to grab your popcorn, you're going to get
A scale, because we're going to measure the
Gotta
popcorn.
bring in that math, guys.
We're going to measure the popcorn before it gets popped, so the kernels, and then afterwards, you're also going to grab a popcorn maker so that we can see the popcorn being made.
All right, there's also observation sheets up on the front desk. So if one person from your group wants to go get the supplies you need, and then the other person from your group wants to come and get the observation sheets, and then you'll also have a recorder at your station. So now that you guys have had time to actually do the experiment, watch what's happening with the popcorn as it's been popping, here are some questions that you're going to discuss in your group. So what did you notice about the popcorn machine? What happened as the popcorn was being popped? What made the popcorn pop? Was it loud or quiet? And then the loud or quiet kind of relates to the form of energy, so make sure you tie that in your discussion. And then what was the weight of the popcorn kernels, and is it the same after it's popped? And why do you think it either is the same or it changed? So you're going to have about 3-4 minutes to discuss this quickly in your group. We're going to put the visual timer up on the board and we'll get you going. And then when you're done, we're going to split off independently, and you have to write at least three sentences for each of these questions. And that's going to be one of your writing assignments for today to make sure you're still staying on task.
So once the students have completed the experiment and they're fully primed on what nuclear fusion is and kind of have a bit of an understanding, we would come back together and we would go through our PowerPoint. In this PowerPoint, we would explain more of what nuclear fusion is, the components of it, and give the students the chance to take what they've learned from the popcorn experiment to our PowerPoint and make those connections.
So now that we have gone over the PowerPoint and you guys have fully got and submerged into all of what nuclear fusion is and how it works and what all plays a role in it, we're going to do an exit slip now. This isn't an assessment, it's just for us as instructors to see what you've learned, what you're understanding about it, and then if you have any questions or you're not fully grasping the material, we can go over it again tomorrow. That way you guys fully understand it, and that way when it comes time for the assessment, you know what it is and you can get it right off the bat.
So to start off, real quick again, our objectives that are gonna be on this exit slip. First, we have describe how energy from the sun is created.
Then you have explain how atoms react during the process of nuclear fusion in the sun.
And finally, we have explained what a photon is and how it is made and why it is important to our Earth.
So at your table, you guys have your exit slips. So the first one we're gonna start with is describe how energy from the sun is created. So now this is the time for you guys to write your answers down, and we'll give you a couple minutes, and when you're finished, put your pencils down, and then we'll go.
Now that we've completed completed our first question, we're gonna go ahead and move on to our second question. Our second question is, explain how atoms react during the process of nuclear fusion in the sun. You guys can either bring in our non-linguistic representation that we've been working on and draw this out, write it in words, do whatever you have to explain this. So now that we've had some time to answer the second question, we're going to go ahead and move on to our third question. Our third question is, explain what a photon is, how it is made, and why it is important to our Earth. You're more than welcome to list these things out, write them in full answers. Just let me know that you know what we're talking about.
So now that we have finished doing our exit slip, is there any last minute questions that we can try and answer now with the short amount of time we have left for class? If the questions are going to get more in depth, we'll go ahead and finish them tomorrow. So any questions? Okay. So I don't see any questions at this time, which is perfectly fine. Go ahead and just think about the material for next class, and on your way out the door you guys can go ahead and put your exit slips in the basket. We might provide some feedback for you on the exit slips, so you'll get those back next class, or we might just have a whole group discussion. That way you guys are seeing where some of the miscommunication is, and then we'll re-go over some of the topics and do a quick review next class period. Have a good class and have a good rest of the day, guys.